to the property lane where it's everything real estate. Once again, my name is Catherine Nanteza and I'm your host tonight. Ladies and gentlemen, we continue the topic on construction. And today we are looking at foundations. Like promised last week, we want to look at this issue of foundation because it is said that if your foundation is not good, the rest of the building won't hold. And so it's problems starting from foundation that cause the building to fall. If your foundation was not well done, was not well thought through, your entire building will come crumbling. So today, ladies and gentlemen, we are back with architect Amara. Andrew, please say hi to the
Thank
viewers.
you, Catherine, for having me here, and it's great to be here again to share with you some thoughts on foundations.
Yes, Andrew, we want to know about foundations. Tell us, where do we start from? How do we ensure we have a proper foundation?
Yeah. So foundations is a very interesting topic because a good foundation really is the start of any successful project. And usually it also is one of the most expensive milestones in any construction stage. And the best place to start your foundation story is you need to ask two questions. One, what are you going to carry? You need to find out what are you going to carry. And then the second question is, how strong are your soils? So usually those two questions need to be answered. And usually if it is a complicated building, usually the foundation questions are answered by a structural engineer. A registered
Not even
structural
an architect.
engineer. No, a structural engineer.
Who is registered?
Exactly. So first of all, what are you carrying? Are you going to carry one level of a residential house? Are you going to carry 3 floors of a residential house? Are you going to carry a disco hall because that people are going to be jumping up and about?
Yeah,
Are you going to carry a car park?
an industrial
Yes. Are you going to carry rain or water? For example, a water pool?
machines. There are these
Yes, a swimming
machines
pool,
that are
for
heavier
example,
than
as
a
well.
building.
Is some weight. So ask yourself, what are you going to carry? And how heavy is it? So those forces are calculated. How heavy is what you're going to carry? Secondly, the things that are going to carry are also calculated. Whatever columns, metal bars, and all those things that are going to carry have also to be calculated. Then there are also other weights on the side. For example, the wind could blow your building. How will your building withstand? So all those things are calculated in what you're going to carry. And these are usually termed as loads. So these loads are worked out and you have that information. The second thing is you look at where you want to build. For example, you can see where we are. Look at your soils.
Yes.
And then you find out how strong are the soils that you have.
So how strong are the soils where we are?
And is it marram soil? Is it farm soil? Is it rocky soil? And there are a couple of tests you can do on the soil. You can take your soil samples to the lab. You can dig down to see, is there any water? Is there any rock? So how strong are your soils? Unfortunately, most builders today do not test their soils. They think it is.
I haven't heard
they
many
don't
people
even know.
testing their soils.
Yes, it's usually the storage buildings that are bother to test their foundations. But most projects that I know of, most residentials, forget about that step. But it's important to test. It's a very important step. So you test your soils, find out how much they can carry.
Does soil testing affect in terms of the wall dump or the cracked walls that we are seeing? Is that also part of?
Well, when you're testing the soils, you test a number of things. First of all, its strength, how much can it carry? What is the content? What is the DNA of the soil? What is the makeup? Is it mainly gravel? Is it fine? Is it loose? Does it have some organics in it? So you test all of that in the soil. It is graded and you know. So once you have that information and also you know how much you're going to carry, then the structural engineer does a couple of calculations to determine what foundations you're going to have. And now that is where we start talking about the type of foundations. Yes.
Wow. So what next?
So
you've tested the soil?
Yes, you've tested your soil.
I was asking you, is this what from your test?
This is marram. This is usually a reddish soil is usually marram. And that is a soil that many builders love because you use it for backfill and it's fairly stable and predictable. But black soil is not as good for construction. It's really soft. It is and it is organic. It is black and it's mainly good for landscaping, right? And then also white soils or finer soils like clay. Clay is also not so good for foundations.
Okay.
And so you have to improve your foundations if you're going to build on such soils.
Okay.
So when your team are coming up with the right foundation, they understand what these soils are like,
Okay.
and then they design the right foundations. For example, you can have a foundation that is... So there are a couple of foundations and different designs that can be made for different foundations. One really popular one is where you have a pad. It's a concrete base, and it's the start of your column. As you can see here, you have this column, and somewhere down over there, there is a concrete pad. That is the beginning of the column.
Okay.
You need to go down, find firm soil, and then a raft of metal is placed down there, and concrete is poured, and then it's the start of your column rising up.
Okay.
However, you could also have what we call a wall, a strip or a plinth wall that also sits on a base of concrete.
Like
and that
how?
runs all the way underneath the building, and then it comes out. So this is a ground beam. Usually when you're doing buildings that are fairly high, or where the soil has different levels, and also maybe where the spans are quite long, there might be need for what we call a ground beam to stabilize the building. And that there is a ground beam. Yes, it's just there to distribute your forces so that they can go into they are spread around the building, stabilizes your foundation, and then that goes down. Another element of foundations could be a retaining wall, which you can see over there at the far end.
Okay.
And that device is just holding back soil. So if you have a steep site and you want to hold back some soil, you can design a retaining wall. Depending on how high, depending on how high it is, you could use bricks, you could use concrete blocks, or you could use, this is completely reinforced because the height that you're holding back is about 3 meters. Okay. So this all is concrete with metal bars, and it is holding back soil.
Okay.
As you are doing your foundations, you also need to manage water, because water can be a nuisance. As you can see here already, water is streaming down when it rains. And you notice there they have put a layer of waterproofing.
Yes.
So if you have a retaining wall in your foundation, you need to think carefully about keeping the water out. And that is something that many people forget.
So that's why they covered it
the water out of your foundations.
Okay.
So you have a retaining wall, you put a layer behind. If you have your foundations and your slab, you need to raise it sufficiently above the water level. So waterproofing is very important, and managing your water, underground water, is also very important. If you have a site where there's a lot of water underneath, there are devices like French drains, where you have boulders underneath to allow the water to flow through, and then you build on top. Okay. If you have a site that is not as strong, you can actually spread the forces in what we call a raft foundation. So this is a mat of concrete, a bed of steel, and then you have your building starting from that point.
I normally see these rocks.
Yes, this is what we call hardcore. You're trying to prepare your foundation for a slab. So you have all these boulders, and then you have your
it's
slab
what you're
on top.
calling boulders.
Yes, boulders or hardcore, really. Another device in foundations is what we call piles. So piles are like a pin that pierces the soil, and you drill down. We didn't have that technology, but recently it is now becoming a bit more common, where you can drill down and just point your concrete pin down into the ground, or your steel pins down into the ground. It's a technology called piles.
So how does that work? It's like you put in at different corners, or I mean, how does it work?
So usually the way it works is that if you're in a precarious site and the farm soils are really deep down, then you actually need to go really further down to get a firm foundation. And usually those columns get their strength from friction. So as you go down, there's that friction, and that it wedges these pins into the ground, and you have something a bit more stable. So foundations are varied. There are so many types of foundations. I think what's important is that your professional team works out the right calculations, works out the right weight you're carrying, works out what is on the ground in terms of the soils, and gives you the right foundations. And you need to go a step further. You need to follow what has been spec'd, because many people sometimes try to cut.
Yes.
They reduce on the bars, they reduce on the size of the pad, they don't dig as deep, they get tired, then there's a problem. Yes, that's a disaster waiting to happen.
Wow.
Yeah.
We are going to take a very short, quick break, dear viewers. And when we come back, we are going to look at what makes buildings fall.
Okay.
How do we ensure we have the right foundation? What are the other types of foundation? You've talked about so far 2 of them. We are going to look at the other types of foundation when we come back. See you shortly. Welcome back from that very brief break, dear viewers. We continue the topic of foundation, and we are looking at it practically here at Crane Heights in Buyab, a project by Universal Multipurpose Enterprises. Andrew, you were still taking us through the foundation.
Yeah.
And you talked about the retaining wall. What's going on here?
So this is a good example of a typical foundation. If you have a storied building,
Okay.
you dig down
Okay.
to find firm ground. You prepare that ground to receive your foundation.
Okay.
So instead of placing your foundation on soil, you prepare with a layer of blinding.
So this is the blinding?
Yes, this is a blinding. Sometimes it could be a concrete,
Okay.
a small wick layer of concrete. And then once you have that layer, depending on the size that has been designed, you then place your base. And this is a base.
Okay.
Before this base is placed, sometimes you'd have reinforcement bars. So you get some metal bars and you make a mat of bars, a
Okay.
cage, depending on the size and the design. And then you pour concrete to create this box here. So this is about 1.5 feet probably, and it goes and extends all the way inside.
Oh,
So
okay.
at the center of this is the start of your column. It's almost like your feet. You know, your feet have a base, and then the legs rise up. So it's the same
Okay.
concept.
Okay.
So you have your column rising up. So all of this is going to be underground. And so we are going to bring back the soil, and that's usually called a
Hey.
backfill. As you
Okay.
can see inside there, they're already pouring soil down there to fill it up and bring it up to the right level.
Okay.
So once this soil gets up to the right level, you come back and compact. And you need to use the right soil. Don't use just any type of soil.
I thought you used the soil you got from
No,
here.
the soil has to be the right quality of
What's
soil.
the right quality
There's
of
usually
soil?
a good marram is usually good. It has to be compacted. It shouldn't have debris, rubbish,
has
or things that will rot. Because if it is not the right content, it will sink.
Oh,
Yes, and you don't want your slab to sink. You don't want this to sink. So that's why it has to be the right soil. It has to be pressed down with the machine, compacted, and then when it is firm, you can actually take a test. You come take a sample, check in the
Test.
lab, is it firm enough? And once it has passed, maybe it could be 99% or 95%. So those are the kind of tolerances that we require. It needs to be
Okay.
really that perfect, because if it sinks, that's when the building cracks. For example, if that half goes down and this half remains up, there'll be a crack in the middle.
okay.
Yes, so the right content is important. You fill it up, you compact, and just for extra strength, you then bring in your hardcore, the big stones that we've had a
Yes.
look at, and you lay that bed so that it is
Even
a good...
after all the
Yes, even all of
compacting.
that. You lay that bed. And then
Okay.
after that, you think about keeping the water out of the building. So you place what we call a damp-proof membrane across the top.
The black one.
Yes,
with
and then
soak
so
cover.
you have to make sure that goes all the way across your building extents, and then you can then pour your slab on top to seal everything underneath. So that process
Wow.
is very important. And as you are mixing this concrete, as you're putting concrete in here, the strength is special. It's different from what you're mixing here. in
So
the walls.
this-
Yes,
this
so the mix here is
particular
different
place
from the
is
mix over
different
there.
from the rest
the
of
stones
it.
should be the right size, as you can see. The stones, yeah. Should be
Okay.
the right size. The cement is very important. These days, there are different grades of cement. You have what we call SEM2, SEM4, but you can go to a lab to actually tell you how strong your concrete is. So then after you have mixed the right portions, you leave it to set. And it has to be...
For how long?
Usually concrete takes about, if it is concrete in suspension, you need about 3 weeks for it to...
What do you mean concrete in suspension?
So concrete so if this is called mass concrete,
This.
so it's all on the, it's seated on the ground, and that's where it is getting its support from. It's on the ground.
Okay.
However, you could have concrete that is from this column to that column, and there's nothing under it, right?
Oh,
so
okay.
it's in tension. Yes, so that you have to hold.
That's the concrete in suspension.
Yes, you keep it supported for about 21 days or 3 weeks or 4 weeks, and you don't want it to dry too fast. So you have to water it every morning like a baby.
Okay.
You water it so that it doesn't dry too fast. You don't want the cracks to appear.
I've
So you
heard
water it
that
every day,
For such tall buildings,
Yes.
you need to give it like 6 months or how many? What's the time?
Usually the
period?
cycle of every slab is about a month.
A month?
Yes, a month. About 3 to 4 weeks. A month, yes. That's the cycle usually. You pour a slab, wait for it to harden.
You don't do anything
dry.
else?
Well, you can do maybe some walling on top, some minor works, but don't remove the support from underneath, so that it gains. Usually concrete takes some time to gain its strength, and that's why you allow it that time, 3 to 4 weeks, before you remove the support. By then, it will have gained its strength. But you know, also there are different materials you could use. You could use steel, you could use timber at the top. But now we're talking about the foundations. Foundations are really critical. In some cases, the distance between your foundations is important as well. So for example, this column, you could decide to omit this column and only keep those two. Also, you have this tying the building together. This is called a ground beam. It is tying your foundation together. Depending on how high your foundation is, you might need a tie beam or not. Over there you have the retaining wall, because it is holding back soil, and so that the soil doesn't cave in. And also the DNA of that wall depends on the height. The higher it is, and that's why
stronger.
That's why we're using reinforced concrete over there with metal bars. But if it is a short, if the height is not that much, maybe if it is waist high, you might use maybe concrete blocks or maybe stones as well to retain. Yeah, so foundations are very important, because this is going to keep the building.
I keep seeing the other thing is these metal bars.
Yes.
I understand there's a size for each part of the building.
Yes.
So for foundation, what size is recommended?
No, the size varies. I mean, it depends on the building.
Because I see the one behind you is bigger.
Yes, it depends on the building you're putting up. If you're putting up a pit latrine, you may not even need what? A metal bar inside there.
Okay.
Yes, but if you're going high, the higher you go, you probably will need a bigger bar.
Okay.
Right? Yes, and then also the spacing is very important. This is where some people cheat, because this spacing here keeps your column intact. If you have a wider spacing and you pour in your mix, you may, the column may tear apart because you don't have that rhythm. So this size usually has to be calculated, and it's the right size. Secondly, these bars, you also have to be careful. And since you have a tape measure or a caliper, you can cross-check, because these days some people cheat on the sizes of
the bars.
Yes, they cheat on the sizes of bars, so you have to be careful. Check the sizes that you're using. Are they from the right place? Also the strength of the bars. There's some bars that you can just bend and
I've been
so you
told.
have to be careful where you are getting your.
So the bar must be
metals.
one that can't bend easily.
Yes, your metals. Yes, and of late, you've heard of earthquakes.
Yes.
Yes, sometimes people have. These days we're getting a bit of earthquakes in the region, especially in the east. So of course, as you're thinking about your structure, think about those questions. If an earthquake comes, can your building stand? If somebody punches the wall, can your building stand?
You know,
if you
when we watch movies, we see people going through walls.
Exactly.
Yeah.
So this is very, very critical.
So we want to go to the other side where there is another slab after the first one.
Okay.
And we want to know what happens. Okay, you were telling us about the soils and compressing of those soils, then after they pour the concrete.
Yeah. Yeah, so after you have compacted your soils, you have a bed of hardcore or these large stones or boulders.
And then the funny thing about this place is there's already one floor there, yet this floor is just starting.
Yes. So this slab is going to sit on the ground. Yeah, so it's really part of your foundation. Whereas in that case, that slab is sitting on columns. So you've already come out of your ground, you have raised your columns, and then you have a slab on top. So and that slab is different from this slab. One. Yes, this slab that is sitting on the ground, you can see you've prepared, you've compacted your soil, you have your hardcore stones, and then you will pour your concrete, and that is your slab, finished, seated on the ground.
Okay.
In that case, that slab sits on columns. So these columns are going to rise up, then you're going to have some support, maybe timber support, we call that formwork. You will put your metal bars, and then pour concrete. Okay. But because that weight is a bit heavy, if you just pour concrete throughout, you lighten the load by having some clay pots. So those are called max spans. So they're usually clay blocks.
The advantage is to lighten the load. I was telling you that I've seen people use heavy concrete in ceilings of a bungalow. But here you're telling me the clay bricks are to lighten the weight. What effect does that have?
So if you have a slab that is really heavy, you need to find ways to carry that slab. Okay. And in order to lighten the load of what you're going to carry, you can use clay pots, and those we call them clay pots, but it's a block made from clay that is fired up, and it is hollow in between, so it is much lighter than pouring your entire suspended slab with concrete. So you lighten the load really.
And Andrew, I'm seeing these bars are different from the ones we were seeing the other side.
Yeah.
I'm told the other side is just going to be a small building, and this is going to be an apartment block. So is this what you are talking about?
Yes, I mean, the higher you go up, the stronger you need your columns to be. And to improve your columns, you look at the size of bars that you're going to use. You also look at the size of the column. You notice that this column is wider. It's about 400 by 200. And even the bar is about 20 mil, 25 mil, compared to 16 or 12.
You mean this wide?
Yes.
Because they are going to be supporting columns.
The higher you go, yes. The higher you go, you need a bit more strength. And so you need to think about having a bigger bar or a bigger column. And it all has to be calculated. You might even have more columns, although the bars are small, but you might have more columns. Or you might have bigger sizes of bars, depending on what you're going to carry. What's important is that it should all be done by a registered structural engineer to work out your forces carefully so that you get the right sizes of bars to use and the right size of columns. And once you get those sizes in your plan, it's even more important that you should follow. So you should make sure that on the construction site, they are following the plan. It is being checked, cross-checked before you pour your concrete so that it comes out well.
What's going on there?
So this is a lift core. As you can see, you have this cage of reinforcement all round. And it's because it's all round, you're going to have a full concrete cover rising all the way up. So it's fairly strong and stable, and it's all concrete. Of course, it must be flush and straight, because for a lift to move, if your tunnel is crooked,
I've seen
the lift car will
that,
not. The lift car will not move. So this has to be accurately done, and then the right holes are put in place so that, of course, you have the openings. It could also help in improving the stability of your building as well.
How does it help?
Well, because you see, this is a lot of concrete that you're going to pour all around. These are so many bars, so this is stronger than just having a small column, right? You're having this entire system all the way, going all the way through the building. So it gives you that rigidity in the structure.
Anything else, Andrew, that we need to know?
I think water management is important, because many people ask the question, why are my walls peeling?
Exactly.
Why is the paint looking
Especially
funny?
in apartments.
Why is
would
it damp?
my wall be peeling?
They start sneezing. And that usually starts from the what? The foundation.
The sneezing starts from foundation?
Well, if you're in a room that is damp, it's not healthy. If there are flakes in the air, it's not healthy. And that's because water is creeping up your walls. So that usually is because of poor foundations. If you have a good foundation and you seal the water underneath so it doesn't climb to the top, or you do the right waterproofing in the right places, you could manage dampness.
Wow. Thank you so much, dear viewers. For those who have been following with us from the start, it's been a pleasure having you walk with us this journey. I'm sure you know what to do with your foundation by now. From my team and from my crew, from our guests, see you next time.
The Property Line.